Okay, students, we're going to solve inequalities today. It's like solving for x, except for we have to use an inequality symbol. Now, normally when you multiply or divide, or actually not normally, but every time you multiply or divide by a side with an inequality, you must switch the equal sign. Well, I'm going to teach you how you don't have to remember to do that by always making sure the coefficient of x is positive. And if it's not, you're going to move it to the other side to make it positive. Then you'll never have to remember to switch the inequality sign. So first off, inequality signs. Greater than, this is reading left to right, that is. Greater than, okay, which would be an open circle, and then shaded to the right. Less than, which would be an open circle, shaded to the left. Greater than or equal to, greater than or equal to is a closed circle shaded to the right. Less than or equal to is a closed circle shaded to the left. Okay, so because you see we have number lines, so we're graphing them after we solve it. So again, how do we solve all equations? Reverse PEMDAS. After you do distributive property, combine like terms, then reverse PEMDAS. So we have no distributive property or combine like terms, so we just go right to reverse PEMDAS. So what is there to add or subtract across? Add the 8 across. So now I'm left with x over 7 is greater than, what's 8 minus 5? 3. Last step, multiply by 7. The opposite of divide by 7, multiply by 7. So let's cancel out. Remember, I'm dividing by or multiplying by positive, so it's not changing the inequality sign. X is greater than 21. So I'm going to just put a hash mark here, put a 21 underneath it. Since it's greater than, notice greater than is an open circle. So I'm going to open a circle here, shaded to the right. Number 2, we have a distributive property first. Okay, so distribute. I have -4, and I can combine like terms there. 22 minus 4 is 18. Now distribute -18 minus 6p. Now I ask myself, is the coefficient of p negative or positive? Well, obviously I can see that it's negative here, so I'm going to move it to the other side to make it positive. So now I have positive 6p, because I'm adding 6p across. And then I subtract the constant across, gives me -36. Okay. Remember, when we move an entire term across, the equal sign is always add or subtract, whatever the opposite sign is. And last step, divide by 6. So I get p is greater than or equal to -6. Okay, notice since I'm always moving the coefficient to the positive side, I'm never going to have to switch that inequality sign. So -6 on the number line, boom, -6 is greater than or equal to. Whenever there's an equal to, I have a closed circle, and it says p is greater than is to the right. So I shade to the right, put an arrow, just like that. Okay, next, examples. These are all examples that you'll see on your worksheet today. Okay. Combine like terms. Remember, that's the first thing in distributive property. So it's 4x right there, plus 6 there, greater than -6. So this coefficient on the x is positive, so I'm going to leave it on that side. So therefore, I'm getting rid of the constants the other side. So I have 4x is greater than -12. Divide by 4, and I get x is greater than -3. So there's no equal sign there, so it's just greater than, so it's an open circle at -3, and x is greater than. You always read from the x side, wherever the variable is. X is greater than. It's greater than because it's pointing to this, always points to the smaller number. So X is greater than -3. Greater numbers are always to the right. All right, number 7, I could distribute, or I could divide by -6 right away. If I divide by -6, then I'm going to have to switch the inequality sign. So it's your choice, because -6 does go into 18 nicely. But if you do that, I'm divided by negative, I have to switch the inequality sign. Now, I remember to do that all the time, but if you don't, it'd be smarter to just keep doing what we've been doing. Distribute -6x minus 24 greater than 18. I asked myself about the coefficient of the variable. It's negative, so I'm going to move it to the other side to make it positive. Okay, so now I've got 6x and a plus 18 there, less than -24. And last step, subtract the -18 across. I get 6x is, oops, don't switch the sign, less than -42. I divide by 6, and I get x is less than -7. So again, -7, what kind of sign? Is it open or closed circle, I mean? There's no equal sign, so it's an open circle. And it says x is less than. Remember, it always points to the smaller number. So x is less than -7. Less than is to the left. Okay, here we go. Again, gonna reverse PEMDAS because there's no distributive property, no combining like terms. So add the 4 across. -3/5 x is less than or equal to 0. So what times x equals 0? 0 does. Okay. Now, here's the problem. I need to, again, make this positive. So I need to move it over there. Zero goes across. Okay, so no, this is still nothing. Now I divide by 3/5. Okay, and I get x is greater than or equal to 0. This is the tricky one. So greater than or equal to, remember that's closed circle, shaded to the right. Now, remember, I can always check another number that I have in my shaded region, such as 5. 5 is over here, so let's plug in 5. Okay, then these 5s cancel out. I get -3 minus 4. Is that less than or equal to -4? -3 minus 4 is -7. Less than or equal to -4. Yes, that is true. Okay, so if I plug in a number that's in my shaded region and it comes out to be true, I've shaded correctly. This is an easy way for you to check. So if I thought, and I could just drop that off and say x is less than or equal to 0, because -3/5 times 0 is 0. Now left is less than, well, then I have it shaded the other way. So then let's check -3/5 times -5. -5 is in the other side there. I don't have shaded. -4 less than or equal to -4. Well, then I get 3. Those 5s cancel out. -4 less than or equal to -4. That's -1. Is -1 less than or equal to -4? No, that's false. -1 is greater than -4. So that would tell me shading over here at -5, if I thought it was shaded on this side, then -5 is incorrect because I plug it back in and I get a false statement right there. So that means it should have been shaded the other direction. So that's an easy way, if you get trouble, is plug in one of the numbers in that shaded region that you think is correct. And if you do your math right, and it comes out to be true, then you've shaded correctly. If you've done your math right, and it comes out to be a false statement, then you've got it shaded on the wrong side. Okay. Lastly here, we have a little geometry mixed with algebra. So we want to find the perimeter of the following. Remember, the perimeter means add up all the sides. Okay. Well, you need to remember from your little geometry in 8th grade math that these hash marks means those two sides are congruent or equal. So notice I'm only giving you one of those. 5x minus 1 is right there. Well, since that's 5x minus 1, this has to be 5x minus 1 because they're congruent. And it gives you BC is 3x plus 2. Now I have all three sides written in there. I want to see it written in just like that. And now I add them all together for the perimeter. So I have 10x plus 3x is 13x. 2 minus a 2 is 0. So it's just 13x. Now, number 12, we have an equilateral triangle. All three sides are congruent. So notice I only had to give you one side, AC, 4x minus 4, because they're all the same. So all 4x minus 4s. So I have 12x minus 12. Okay, now notice down here, little m stands for measure. This is the angle symbol. Measure of angle C. Well, if it's equilateral, it is also equiangular, which means all three angles are the same. And everybody should know from elementary school on that the total degrees of a triangle is 180 degrees. So I have 180 equals 3x, because every one of these I can put down as x, or whatever variable you want to use. They're all the same. So now I just divide by 3, and I get 60 degrees. So the measure of angles C, A, and B are 60 degrees. They're all congruent. Okay, lastly, I give you the angle measures right here. So there's angle A, angle B, angle C. And it says find each angle. Okay, we gotta first solve for x, then plug it back in. So I know all the angles add up to what again for a triangle? 180. So I just add all this up. So adds right down 9x, 15x plus 8 equals 180 degrees. Subtract the 8 across. 15x equals 172. Okay, divide by 15. Put on your calculator. 172 divided by 15. 11.46 repeating bar. 11.46 repeating bar. Remember, the repeating bar is only over the 6. So that's what x equals. Okay, now I need to plug that into the x right there. So I can leave that in my calculator, times it by 5, and then add 1. So take that answer, times it by 5, equals, and now add 1, plus 1, equals 58.3 repeating bar. So angle A is 58.3 repeating bar. Okay. Now, I can plug it into either B or C. So we'll just do B next. 4 times 11.46. So now I have to go clear 11.4. And I have to do 666. Okay, that's enough. Times 4 equals, and what was it? 4x plus 5. So I'm going to add 5. 50.86 repeating bar. 50.86 repeating bar. Okay. Now I could plug it back in, do 6 times that, or I could look at 0.86 repeating bar plus point. Oh, I need to do it. Okay, so 6 times 11.46 repeating bar equals plus, how much of that? Plus 2. Plus 2. So 70.7 7, and then 9 repeating bars actually moves it up to 8, 70.8. 70.8. Okay, and there's my 3 answers. So that one needed a calculator to plug in. All right, that goes ahead and explains your worksheet.